9.3, we will be discussing circles. This equation for a circle is relatively straightforward compared to some of the other ones we'll see. But here it is. X squared plus y squared equals r squared. In this case, r is the radius of the circle. The circles we're dealing with today all have centers at 0, 0. The definition for a circle is the set of all points that are a given distance r from the center. So you end up with your circle here. It goes through r0, 0r, negative r0, and 0, negative r. We don't usually bother to find the points between these, although you certainly could using the equation. If you pick a y, you'll be able to find the x that goes with it, or pick an x and find the y that goes with it. Today what we're going to do with equations is graph them. Then we're going to, from descriptions or graphs of circles, we should be able to write the equation for the same circle. And then we're going to find the equation for lines tangent to the circle. In case you don't remember from geometry, a tangent is a line that touches the circle once, like so, and just touches it at exactly the one point. We're going to write equations for that. And then for distinguished circles and parabolas, there's a section where there's a bunch of equations. You have to graph them all. Some of them are circles and some of them are parabolas. So let's start with number 1, graph circles. Let's take the equation x squared minus 4 equals negative y squared. So this equation is not in standard form for anything. The x squared and the y squared, neither one of them is by itself, and they're on opposite sides. So when I see that the x is squared and the y is squared, then I know I need to go to standard form, which means I want to actually get the x squared and the y squared on the same side. I want to move the 4 to the other side. So I add y squared to both sides, and add 4 to both sides. So I'm looking at this. The way to distinguish a circle from the other conic sections is that circles are going to have an x squared and a y squared, and they'll both be the same sign. So in this case, both positive. In fact, if they're both negative, what you want to do is move it to the other side so they're both positive. X squared plus y squared equals 4, which makes it the equation for a circle. If you prefer, you can write this as 2 squared, and that way you can see the radius right there. This is a circle with center at 0, 0 and radius 2. So I draw my axes. You should indicate a scale. 1, 1. So 2 is here, 2. All the points that are 2 spaces away from the origin are in my circle. So I find them on the axis because they're the nice ones with whole numbers, and then draw my circle. Pretty straightforward. Make sure you indicate a scale. On a lot of these, you probably don't want to go by ones, but make sure you indicate if you're going by something else. So let's see, for our second example, we're going to get a description. So we're going to say negative 4, 7 is on a circle with center 0, 0. Center at the origin. Write the equation. So given a point anywhere on the circle, and you know where the center is, you can find the radius. What you need to do to find the radius is find the distance between those 2 points. Negative 4, 7 is like, I don't know, this point right here. And so negative 4, 7 is right there. We need to find the radius, which is the straight line distance. So the distance formula says you subtract the x's and square them. So negative 4 minus 0 squared plus 7 minus 0 squared, which gives me 16 and 49. So d equals the square root of 65. Now don't worry about trying to find that square root or even simplify it, because in our equation we're going to use r squared, not r. So we just put x squared plus y squared equals, and the square of the square root of 65 is just 65. So that's a nice shortcut. When you're using the distance formula, don't bother finding the square root. because the square is going to cancel the square root. You're looking for d squared, not just d. Okay, thirdly, equation for a tangent line. A little piece of geometry that hopefully you remember, but it's okay if you don't, I'm going to remind you, is that the tangent line to a circle is always perpendicular to the radius at that point. Tangent lines are always perpendicular to the radius. So if we're given a point on a circle, in this case 5, -6. So if we're given the equation for a circle and a point on that circle, 5, -6, or if we're given a point, we should be able to find the equation for the circle. The idea here is then I need to find the point perpendicular to my circle at 5, -6, which means it's going to be perpendicular to the radius there. And the radius, it goes from 0, 0 to 5, -6. So we can find the slope of the radius, that being -6 minus 0 over 5 minus 0 is -6/5. So the slope of my tangent line is going to be perpendicular to that, which means change the sign and find the reciprocal. So -6/5 becomes positive 5/6. And that gives me a point and a slope. So I can use point slope form, y minus y1 equals m times x minus x1. And that means y equals 5, 6 x minus 25/6 minus 6, which is 36/6. So that's -50/61/6. So there's the equation for the tangent line. Find the slope of the radius, take the negative reciprocal, and put it into point slope form. That's number 3. Lastly, distinguish circles and parabolas. At this point in the chapter, it's fairly, there's only 2 things we know, and they're fairly distinct. So if I'm looking at some equations, and I see y squared minus 16 equals -x squared, and I see there's a y squared and an x squared, I put them both on the same side, move everything else to the other side, and I have an equation for a circle. This one has radius 4, because 4 squared is 16. Whereas if I'm looking at a parabola, what I will see is one of them will be squared, and the other one will not be squared. And that's how I know it's a parabola. Only one of the 2 is squared. Parabolas that we're going to see for now, because we're keeping them at 0, 0, will not have a constant term at all. You should be able to graph parabolas still from last time. So I'm not going to go over that, and we graphed circles already. So that means it's time to get started.